All right, everybody ready? We are looking at areas of trapezoids, rhombi, and kites today. So we're going to learn two new formulas. Here is our first one. Trapezoids are very, very similar to triangles. The difference between a trapezoid and a triangle really is that a trapezoid has two bases, where a triangle only has one base. That's why our formula looks so similar to the area of a triangle formula. The only difference is that instead of 1/2 height times base, we have to add the two bases together, base 1 plus base 2. So that's where our formula is coming from. Another very important thing, this is probably going to be the most missed thing or the most incorrect thing that I see on this next quiz, is that for trapezoids, we have to make sure that whatever we pick to be the bases are the two sides that are parallel. That is super important. We can't just pick any two sides of this trapezoid. It's got to be the ones that are parallel. Usually they look parallel in the picture, so you can tell that those are the two parallel sides. So in this example, I can see this side and this side look to be parallel, so those are going to be my bases. And once again, height is always going to form a right angle to one of those bases. Where does this formula come from? If you care, there is a long, wordy explanation for how we get there. But it's basically we take the trapezoid, we make a second one, we flip it upside down, and when we squish them back together, it's a parallelogram. So basically, you're taking half of a parallelogram formula. That's where this is coming from. It's all there if you want to see it. Notice, a lot of the times, our height in a trapezoid, here's our two bases. Oops. A lot of the times our height in a trapezoid is going to be on the inside. This is very, very common where we have something that looks like this. Other times our height might look a little bit weird. Again, we're looking at where are the two bases that are parallel. The two sides that are parallel are here and here. So the height is whatever's perpendicular to it. It's out here, which is fine. Sometimes it just looks weird though. Height can be outside of the trapezoid, it can be on the edge of the trapezoid, it can be inside the trapezoid, lots of different options. Any questions on the area of a trapezoid formula? The next formula that we're going to learn is for rhombi and kites. Rhombi and kites are two different shapes that we learned back when we did quadrilaterals, but to find their area, they use the same formula. That formula is 1/2 d1 times d2. D stands for diagonal. These are the only formulas that use this diagonal. And the diagonal in one of these examples is, it goes from one corner to the opposite corner. So it goes right through the middle. So in a rhombus, which is this thing on the left here, there's D1. We usually have a longer one and a shorter one. They're both cut in half by each other. That's one of our rhombus properties that we're going to see often. So there's diagonal 1. Here's diagonal 2. Again, they cut each other in half. We're going to use that quite often. Same thing here with the kite. Kites are a little bit different than rhombi. They don't have all four sides pieces congruent. Instead, if I take a look at diagonal 1, it is not cut in half, but it does cut this diagonal in half. So kind of some different properties for those kites and rhombi that we need to remember from the quadrilaterals unit. But it'll be pretty obvious when we look at a picture. Where do these formulas come from then? How do we get that the area is 1/2 diameter, or sorry, not diameter, 1/2 diagonal 1 times diagonal 2? We're going to imagine that we take this rhombus and we're going to put it into a rectangle. Oh, that was a terrible rectangle. To find the area of this rectangle, I would be doing this diagonal 1, which is like the length, and then diagonal 2, which is like the width. I would multiply them together to get the area of that rectangle. And then to find just the area of the rhombus on the inside, that's when I'm dividing it in half to get rid of all this extra nonsense out here. Same thing for the kite. It's the same reason. So if that helps you think about that, then that's why. Questions on these two formulas? Make sure your little half sheet, your blue sheet, is filled in with those two new ones. And then we're going to move on to these examples. So the first three are all trapezoids. I'm going to rewrite that formula up here really quickly. It is area equals 1/2 height times base 1 plus base 2. We are going to be looking for those three parts, and the most important thing that we're going to be looking for is to make sure that we have picked the bases that are parallel to one another. So in this diagram, the two bases that are parallel to one another are here and here. Everybody agree? Do we currently have the height found in this diagram? No. We have that slanty side, but that is not the height. Remember, height's got to form a right angle. So that's going to be this guy right here. Now to figure out what that height is going to be, I'm going to go back to my right triangle properties because this is in fact a right triangle. And I got a bunch of different methods. I know 30, 60, 90s, 45, 45, 90s, SOHCAHTOA. This one's just going to be Pythagorean theorem. I'm going to find this little top sliver up here by doing 16 minus 11 to get that that's 5. And then my triangle has bases of 5 and h. The hypotenuse is 13. Maybe you recognize that that's a Pythagorean triple and you don't have to do any of the extra work. Maybe you don't recognize it and you set up Pythagorean theorem anyways. 5 squared plus h squared equals 13 squared. We're going to get h is 12. Any questions how I got that? Okay. So then let's plug everything in. Area equals 1/2. The height is 12. Base 1 plus base 2, 11 plus 16. You can put this whole thing in your calculator all at once, which is what I tend to do. As long as you remember those parentheses where they're supposed to go, you shouldn't run into any calculator problems. That end up being 162 units squared. Any questions on that one? We're going to keep going. We're going to make them a little bit harder now. Okay, number 2. What are our bases here? Dahlia? Perfect. Do not let it trick you. 24 and 22 are our bases because they are parallel. Maybe make yourself a little note up here. The bases are not 12 and 10 are not bases. They're not parallel. And then what's the height then? Height is going to join our two bases. So it's got to go from one base to the other. Caitlin? Perfect. It's the one that joins the two bases and forms a right angle. So the area here, 1/2 times that height times base 1 plus base 2. Put it all in your calculator. I got 230 units squared. If I'm going too fast at any point, let me know. But I'm just going to keep breezing through if anybody's got no complaints. Take a look at number 3. Here's where things get weird. If I ever see 45, 30, or 60 degree angles, my brain is automatically, or it should automatically be going to special right triangles. How am I going to solve this using special right triangles? We're going to take this apart. What things do I have in my formula? What things do I need to find in my formula? I know that I have one of the bases. Let's call this base 1. I do not know this second base. And I don't know the height of this trapezoid. So the very first thing that I'm going to do, I see those 45 degree angles. I'm going to draw in a height so that I can use those 45 degree angles. We're going to call this H. So using those 45 degree angles, if we remember our 45, 45, 90 triangles, I'm going to take that hypotenuse, 3 radical 2, to get from the hypotenuse to the leg, I'm dividing by radical 2, which makes each one of these 3. Anybody happy with that? So I now know my height. Now I got to figure out what this length of this base is. Do we recognize that in the middle here, I've got a rectangle? So if the top is 14, then the bottom should also be 14. 3 plus 14 plus 3 means that that second base, base 2, is 20. Then area, 1/2 height times base 1 plus base 2. is going to get us 51 units squared. Any questions on trapezoids? Hoping I didn't go too fast. Okay, flip it over. Let's talk kites next. In kites, it is important to remember that both of the diagonals are not bisected. There is the shorter diagonal that is going to be cut in half. So in this first diagram, something that I like to mark in the beginning is that this shorter diagonal, these two pieces are congruent, just as a little reminder to me. A lot of the times you're going to see this important information listed off to the side for these kites and rhombi. I don't know why they do it. But this tells me that DB is 12. That's my first diagonal. I'm going to call it diagonal 1. I need to figure out what the length of diagonal 2 is, which is this guy right here. I don't have any 30, 60, or 45 degree angles. So the next strategy that I'm going to use is what? I'm going to figure out these missing pieces. I'm going to call this one X. I'm going to find X. Any ideas? When we can't use special right triangles, Anna? Yeah, we're going to use tangent. So maybe we draw this triangle out to the side if it helps us. Oh, that was terrible. But I have something that looks like this, right? I have the opposite and the adjacent, which means I'm going to use tangent. 25 equals 2 over x, where x equals 2 divided by tangent 25. We're going to just get this as a nice decimal. We're not going to worry about simplifying this. This is 4.3. So each one of these little pieces is 4.3. Area, I'm now going to take 1/2. Don't forget that 1/2. A lot of people drop that 1/2. 1/2 is important. 1/2, diagonal 1, which is 12, times diagonal 2, which is 8.6. Another super common mistake is that people take this 4.3 and they put it right into my formula. Do not forget to double it. This ends up being 51.6. Questions on that one? Okay, moving on. Kind of hard to see. Hey, look at that. I've got a 45 degree angle in there. That's awesome. That means I can use 45, 45, 90 triangles. So again, in my kite, I'm going to start labeling things. The shorter of these diagonals is going to be bisected. It's going to be cut in half. I know that 11 radical 2 on the outside means that this is also 11 radical 2. So now I'm going to use this 45, 45, 90 triangle, this one right here, to say that each one of these pieces is congruent. Those are my legs that are congruent. And to get there, I'm going to take 11 radical 2 and divide it by radical 2. So each one of these legs is 11, which makes this 11. Here's diagonal 1. 11 plus 5 is 16. Here's diagonal 2. 11 plus 11 is 22. Area, 1/2, 16 times 22, which is 176. Good? Following? Everybody's okay with that? Let's move on to rhombi. Now with kites, only one of the diagonals was bisected, so that's all we could say about the kites. But for rhombi, what's really nice, I can use it in this first example. What's really nice about rhombi is that both of the diagonals are cut in half. So if I draw in my second diagonal there, that 24 gets cut in half. This is each 12. And I can say that each one of these pieces of my diagonal is both x and x. Another Pythagorean triple, if you can recognize it. Maybe if you don't, you use the Pythagorean theorem to find what x is. But x is going to be 5 here. So 5 and 5. So our diagonals, diagonal 1 is 24, diagonal 2 is 10. Area equals 1/2 24 times 10, or 120. I'm hopefully not torturing you too much. Are we good with that one? And number 2, I look again. Look at that, I see a 30-degree angle. That's probably a sign I'm going to use my 30, 60, 90 triangles. So let's fill in what I can. If that's 22, I know that this is 22. I don't know what these guys are yet, but I know that they're going to be congruent. If I take a look at I want a different color. If I take a look at just this triangle right here, I have 30, 60, and 90. This is 22. That's my long leg is 22. What I need to find is this short leg. So I need to divide my 22 by radical 3. I am really not going to need exact answers here, so if you want to go ahead and round that right away rather than rationalize that, I'm totally fine with that. This rounds to 12.7. Again, we're not going to forget to multiply that by 2. So diagonal 1 here is 44, and diagonal 2 is 25.4, I believe. Which is 558.8. Okay. Any questions on that? I'm sorry if I went too fast on any of that. I'm trying to get this done. Are we ready for the last different kind of thing that we're going to see? Okay. We're going to see these kinds of problems pop up more and more frequently as we get into this unit. Eventually, I believe we're going to have an entire section that just looks like problems like this. These are find the missing dimension problems. So they're giving you the final answer. In this case, they're telling you what the area is and asking you to go backwards to find the missing piece. They're either going to give it to you in a word problem or they're going to give you a diagram. In this case, they've given us both. Here's how I want you to start these problems. This is the work that I want to see written down. The first thing you're going to write down is the formula for whatever shape you're looking at. So if I'm given the area of a trapezoid, I'm going to write the area of a trapezoid formula, which is 1/2 height times base 1 plus base 2. In that formula, there are 4 different variables. There's area, height, base 1, and base 2. We should have, or be able to find, 3 of those variables. And we're having to find the very last one. So I'm going to go into my word problem here, and I'm going to start labeling what those variables are. It says the area of a trapezoid is 128 square feet. That's my capital A area. One base is 12 feet. Let's call that base 1. The height is 8 feet. Let's call that H. The last part that I need to find is the other base. We're going to call that base 2. So this is the step that I need to see in your work, is now I'm going to take each of those variables and just plug them in. 128 equals 1/2. Height is 8. And then I got base 1 is 12 plus base 2. That's the step I want to see. From here, we're solving for base 2, so we're going to use reverse order of operations to figure out what that base 2 is. I'm going to multiply the 1/2 and the 8 together. I'm going to divide by 4. And I'm going to subtract 12. And I believe this is in feet. Any questions on that?